Hello everyone. From this point we start diving into the operators. I want to start with scans, seeks, and lookup operations, which we call data access operators. Each database in SQL Server contains at least one data file and transaction log file. Each data file contains 8 KB size data pages. SQL Server extracts data from disk at page level. Each page contains the actual data and the group of pages are located in heap. Heap is group of unsorted, unclustered pages. Now suppose you run this query against heap. In this case, what SQL Server does is it will look at all the rows in the heap person2 table and bring business entity ID from test table if first name is Abe. As you can see, we are searching each row one by one in heap. This is called table scan. Let me show you a real example. This is the example person2 table. As you can see, I don't have indexes in this table. Therefore, this is a heap table. We enable actual execution plan and run this query against this heap table. You can see table scan operator now. You can see here actual number of rows read equal to around this number, which is equal to the number of rows in this table, which means we are reading all the rows. Now we understand table scan. To scan all the rows is costly. Therefore, we need indexes. There are two types of indexes in SQL Server, clustered and non-clustered index. I will start with non-clustered index. First, index structure. Index structure is based on the tree structure. First level is called root node and contains one root page. After root node, here comes middle nodes. Middle node may consist of several levels based on the data. In our case, it contains of only one level since we have very small data. After middle node, lastly comes leaf node, where index structure ends. Let's see how the flow of query in this architecture works. We run this query. First, the flow starts with a root page and SQL Server defines Jack and Murphy rows there. SQL Server understands that James is between these rows. Therefore, it selects page number 33 and then it goes to page number 33. There, SQL Server finds Jack and Lauren. It understands that James should be in 169 since next row is already starting with letter L. As a result, page number 169 is selected and James row is found there. Here we find that James is located in file numbered 1, page numbered 402, and in the first row of heap, or heap table we can say, then the result is returned. If we have several records of James, we would have many records in the leaf node here. All the operations we just saw is called non-clustered index seek with row ID lookup in SQL Server. Let me show you one real example. We first create non-clustered index. Then this is an example of non-clustered index with RID lookup. Here, as you can see, only one row is being read, which is much efficient and less costly. Sometimes, even if there is non-clustered index, SQL Server does not do index seek with RID lookup. Instead, it does table scan, non-clustered index scan, or non-clustered index seek without RID. When? For example, you created index on the first name. When you don't use this first name column as predicate in where clause, SQL Server does not use non-clustered index. Instead, it just does table scan. Also, if you do not use first name in where clause but you are selecting only clustered first name column, non-clustered index scan operation is used. In other words, it just goes through the leaf node pages instead of going and searching in for heap table. This is much efficient in this case. Finally, if first name is used in where clause but only indexed column is being selected, non-clustered index seek without RID is used. For example, here, when James is selected, there is no need to do row row ID lookup, as we need only first name column and it exists already in leaf node page, right? Let me show you example. I created index, then I run the below commands where clause is there. Okay, you can see table scan operation here. Then I select another column, which is first name here. Now you can see we are doing index scan. Finally, if we use only indexed column with where clause, non-clustered index seek without RID is being used. There is also one more very much important point you should know. For example, when we run this query, we know that SQL Server does non-clustered index seek as we are selecting only indexed column, which is first name, right? Now, what happens if I select non-indexed column, which is last name here? It does table scan. What if I change the value to Abe? It does index seek with RID lookup. Interesting, right? So let me explain that. The main reason is selectivity. Let's see how many records for Abe and Richard here. You can see selectivity of Abe is very low compared to Richard. In other words, what SQL Server is doing is it is just comparing cost of scanning whole table against the cost of index seek with RID lookup. In this case, it looks at selectivity. In the case of Abe, going through the whole table for one record is more costly. Therefore, SQL Server selects index seek with RID lookup. But in the case of Richard, going through the whole table is less costly rather than doing RID lookup, because there are many records of Richard. To summarize, until now, we looked at scan and seek operations when there is no non-clustered indexes. Let's now focus on clustered index related scans and seeks. The difference between non-clustered index and clustered index is that in a non-clustered index case, as you might remember, a pointer to the actual data, which is called RID, is stored at leaf level, right? But in clustered index, the actual data itself is stored. For example, we created a clustered index based on first name column. As you can see, the leaf node now includes the actual data pages which is sorted based on the clustered column first name. The only main difference is that between non-clustered index. Therefore, we cannot create more than one clustered index for a specific table. Scan and seek operations are nearly the same with clustered index case, okay? If only a particular column can be selected at leaf node, we call it as clustered index seek. If all the rows are scanned, we call it clustered index scan. There's no so much complex thing here. For example, we create clustered index on first name. If first name is used in where clause and selectivity of first name is low, index seek is used here, selecting only a particular row. On the other hand, clustered index can be used when first name is not used in where clause, of course, and the selectivity of first name is high, or cost of scan is lower than seek. Let me show you a few examples. First, we create clustered index. Then, by running this query, we can see index scan is being used, because we are not specifying indexed column in where clause. Also, again, by running the below command, we can see selectivity of Richard is high. As a result, if we run this command, we can see index scan is being used. If we run with Abe, we can see index seek as selectivity of Abe is low. This is the same with non-clustered index case, right? If we have many rows like Richard, we had better do scan operations rather than seek, because it is less costly. Therefore, selectivity of your row is very much important in both clustered and non-clustered case. And you should create index on correct column where selectivity is low. Okay, let's discuss about the case where we have both clustered and non-clustered indexes created by using following commands for the same table. In this case, as you can see in the leaf node of the non-clustered index, business entity ID has been set instead of row IDs. Because we have clustered index for this row, okay, for this column. For example, if we run the following query, we will end up with the following flow. We call this as key lookup, okay? Key lookup, we just start from non-clustered index and it is ending with clustered index. Let's try this in SSMS. We create clustered index on column business entity ID. At the same time, we also create non-clustered index on another column, first name here. If we run this query, we can see key lookup case. I hope now you are much clear about seek and scan operations, which are very important in understanding execution plans. Let's keep learning.